Alrighty, happy Thursday. We got through pretty much everything we wanted to with array-based sequences. Right? I didn't actually open the textbook. You guys can do that. I'd like to imagine you read the book. I forgot, I need to remember to post the quizzes because having a quiz tends to make people read the book because it's open book, open notes. Like you look at it, you're like, oh, where's the answer to this question? And you go find it. So I will post those when I remember. Apologies for the delay on that. I didn't just wholesale like copy everything from last time, so that was not needed. All right, so we got to talk about Project 0 and then the next project, Project 1. Should be lots of fun. So let me pull up the assignment here and I'll fire up PyCharm. How to go with Project 0? Awesome. Just some practice here with our classes and inheritance. Lots of good things here. And then testing. Right? Making sure it does what it's supposed to do. Right? We love unit tests, they're fantastic. It turns out because of inheritance, there's actually less for us to test because we only have to test the special stuff. Right? If we've tested it in the base class, I don't have to test it again. I just need to test what's special about this class, what's new in this class. Right? 2001, winter, 2025, this is Project 0. All right, hopefully I got that in the right spot. This one I want to close, thank you. All right, and again, I like modules. That's just my style. If you don't like modules, that's okay, I don't really care, right? You know, we did it. I assume you know how to because we've done it once. I'm gonna do one file per class because I like it. I like the Git history, keeping one class per file, just nice and clean. Not everybody does, and that's okay. So it's not right or wrong, it's just a preference here. So we'll call this one unit. Right, then we have our class for unit. We have an init method here, and unit has a couple things, right? It's got an attack power, it's got hit points, it's got a range, it's got X position, Y position, a team, and is alive. Right? So we need some attributes. Sure. Now we can either accept these as arguments, or we can have set and get functions for them if we want them to change. Now, thinking about these things, right, and how this sort of stuff works, if we've got functions for move, we probably aren't changing our X and Y directly. Right? We're probably interacting with the function move that goes and changes these things, right? So we don't just let whoever's using our code go and put it anywhere it wants, essentially here. Team probably doesn't change, right? I don't think we've got anything that changes your team, right? So probably don't need a set for that. Like once you're on this team, you're on that team, right? Is alive, this is based off of our hit points, right? So honestly, we could just like sort of generate this if we wanted to. Having an attribute saves you like tiny bits. So there's like some optimization chances here and there. We can do that. Your attack power might change, maybe. Maybe that's like you could get a buff for your unit. So if you had one, cool, that's okay. Hit points you probably don't want to be setting directly. Right? It probably should do something here with your hit points, right? You can attack your target to change their hit points, or you can rally them to restore their hit points, right? We've got some ways of changing hit points here. So not everything has to have a set, right? Just you want to think about what makes sense to have a set here. So we've got unit, so we'll have self.attack power. And again, if we're not giving public sets, we should probably mark these things as private so people aren't changing them here, right? So attack power, I'm going to put it 0 for now. I'll come back and change some of these in a minute here. We'll have attack power, we'll have hit points, self.hit points, 0. Range, X position, can I just copy paste? I can probably just copy paste, right? Self dot range 0. Actually, no, this one we wanted square root of 2, right? So 2 to the 0.5, right, for our range. Self dot X position, and again, probably a private attribute here, probably a private attribute here. Position, start at 0 till we know otherwise. Self dot Y position, starts off at 0, sure. Self.team equals, I don't know, something for now. We'll come back to that. And then self.isAlive You know, I actually just kind of want to get rid of this one here and just leave it as a function. If you had the attribute for it, great, because I said it. But again, you know, we can make the argument it doesn't really make sense to have that one here, right? So our define is alive just returns self.hitpoints greater than 0. Right? That's it. If you have hit points, you're alive. If you don't, you're dead. Right? This probably is pretty easy just as a function call rather than attribute, because then we have to remember to change that attribute every time your damage changes. That's all. Both can work. Either way is fine here. So either approach was okay. Not to worry here. So for things we don't want to change, we have to take as arguments, right? If we're not giving you a public set for this, we have to take it here. So we should probably take an attack power here. We should take a hit points here. We should take a range here. Take an X position. Take a Y position. And a team, right? So we can just take all those as arguments, right? So here's our attack power. Here's our hit points, here's our range, here's our X position, here's the Y position, and here's the team. Right? So we'll take all of those, and then we need some get functions here. Again, I'm feeling particularly lazy here, so we'll just go ask the chatbot. Right? This is a shining example for chatbot, right? You know, generate get functions for this class. And we paste in the class, right? And then we quote it. Here, I asked UMGPT for this. UMGPT, here's my prompt. Great. And it should hopefully by now have given us some code. Fantastic. Here's our gets. Makes life easy for us, right? That's great. That's my expectation. Right? If you type them up by hand, great. That's a good typing exercise. But at this point, it's not really interesting, right? This is just super boring functions, right? So we've got those for unit, and we should have some functions, right? Should have an attack function to do something here, and then we should have a move function. So unit doesn't always really know how to do these things, right? So maybe we just define them here, like move, and then we just do nothing, right? You could add a pass in here or something like that. It's okay. And then define attack. Now, this one does some stuff, right? I think just a basic unit should be able to attack, right? We have to check its team. We have to see if it's within range. I'm sorry, I used triangle theory. That's not the technical term for it. My apologies. It's what the distance between 2 points, or the distance formula. Yeah, I don't know words. I'm bad at words. So hopefully that made sense, right? So we should be able to attack. That should work, but I don't really know how to move because the other classes here have like specific movement options here for us. So if we don't know how to, that's okay. We don't really have to. All right, so then we want to figure out attack. So we have to see, should we attack them? Right? And I always like breaking things down into smaller problems, right? Because I think that's entertaining here. So if self.shouldAttack, so attack needs a target, right? Who are we attacking? We're attacking a target. So if we should attack the target, right? And self dot is within range of the target, then we can go do something, right? If we should attack them and they're within range, we'll take the target dot hit points, and well, we need a way to change their hit points, right? We don't really have a good way to do that. The hit points should stay between 0 and max, so we need a way to go do something here, right? Okay, so we can write a function for it, maybe? So define like damage, and I don't know, damage points or something, I don't know, points. We'll take our self.hit points and we'll subtract the points from it, right? But then we want to make sure it's within range. So if self.hit points is less than 0, we'll just set it to 0, right? Because we didn't want to go negative, right? The idea was it stays between 0 and max. So well, if we have a max here, we need to know what our max is, right? Again, the directions are kind of vague on purpose, right? When we get software instructions for solving, like this is the problem you have to solve, you don't always get all the details. You know, ideally we give junior engineers more details, but you have to think about what makes sense, right? So, okay, well, if I need to be tracking what my maximum hit points are, that probably starts as my hit points, right? So maybe I have a self dot max hit points, that starts at my hit points, right? It's possible someone makes a unit at half health, but again, we don't know. It's a little bit unclear, so we'll start with something that we think makes sense. So we can do that, and then we can also check, hey, if self.hitpoints is greater than self.max hit points, then we'll set our self.hit points equal to the self.max, right? Put yourself back at max, right? Stop there. So this is some quick bounds checking for us here, right? Sure, you want to do some damage? Go for it. So if we should attack and they're within range, we'll damage the target for self.attack power, right? We'll do whatever our attack power is damage to that unit. That's attack, right? Well, now we need to figure out how do we know if we should attack, right? So we got to add some more functions. So a should attack function given a target. So if self.team is equal to, what do we have here? We had a couple teams, right? We had an us, we had a them, we had a chaotic. So if we're chaotic, yes, we should just attack everybody, right? Or if self.team does not equal target.team. What is this? Warning us. And really, if this is true, return true, we can just say return this, right? Just go return that. And it's warning us, hey, we probably shouldn't access team, right? That's private here, so sure, we can go get team, right? And actually use the public function, because that's slightly more proper, right? It still works, and it's okay, because we're still within our own code, but it's just slightly more proper, okay? So should attack, fantastic. And then a is within range, is within range, given a target. So this one we have to calculate, right? The distance between our 2 points squared plus x distance squared plus y distance squared equals the square root of the distance between the two, right? So we can return here, now kind of all in one, right? Or for some order of operations maybe. So self.x position minus target.get x position, get x position squared plus, we'll do this again for y, self.y position, target get y position, right? We want all of that, right, to the 0.5 to get the square root of that. If that's less than or equal to self.range, then they're within range. This is, if it's true, return true, so just return it, right? Here, square that one, take the square root of that, see if it's within our range. This probably works for square root of 2, right? It'll probably get pretty close, right, for our defaults. So we can actually give a default then for range, right? If we know range has a default value, we should take that one last here, or give some other defaults, right? Because if you want default values, they have to come at the end of your list here. Range equals 2 to the 0.5, right? So we'd have to have other defaults here, maybe for x or y or team, whatever we wanted, if you wanted this one to be a default argument. Right? Remember, it has to be at the end of our list here. Otherwise, it gets really confused trying to do positional things and default arguments. So, all right, so I think we've got unit, right? All the gets are super boring. We don't really know what to do with move, right? No, move, we said like either x or y changes by no more than 5, move 1x or move 1y, move 10x or y at a time. So we probably need to know which direction we're going and by how much, or, we've got some options here. It might be easy then to take like an x change and a y change or something. Right? And at some point we can check, hey, one of them should be 0, and then we take the other one within, lots of different ways to go about move here. We've got some choices here. But this way you can move your pieces around the board, this little two-dimensional board here as we go. All right, so I think we've got unit, so we should write some tests for it, right? Make sure these functions work. So we want to go to test, create some new tests. Now, all the gets are really boring. We can test them all at once if we want, call the init method, test them all at once. We don't need to do them all separately here. Move, we know isn't actually doing anything yet, so we're not going to test it. We should figure out if damage works, probably, but that'll happen when we use attack. So like, testing the attack is about everything, and then, I don't know, maybe one more for just a basic init, where we check all of them here. So I'll just check one more box, and we can always rename that one later. So this is, I don't know, test init here. So we're going to arrange, we're going to act, we're going to assert, right? So we need a bunch of things then, right? And then from unit, import unit. So we need all of those values here in unit. We need an attack power, hit points, all these things, because we're going to go set them, make sure we get them back out, right? Excuse me. So we'll have an attack power equals something, a hit points equals something, max hit points. Right? Now, we never actually really use max either, so we don't need to check that one here. We'll have a range, an X position, a Y position, and a team here. So, and then all of these are the expected values, right? So I'll say these are all the expected values here, expected, 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 and we'll go set them to something like 5 and 5 and 5, 5 and 5 and team. Like the values themselves don't particularly matter what they are. We just, can we go get them back out? And maybe it's better to make all these things slightly different. 5, 6, 7, 8, 9, because if we were to write the code ourselves, it's possible we returned the wrong thing. So it's probably better to check it this way here, right? All right, great. So we've got them all expected, and then we'll have an expected is alive as well. Should be true. Capital T, true. There we go. And the lack, we'll call our code. Well, the code we're calling is the init function here. So we'll make a unit. So I don't know, unit equals unit, given the expected attack power, the expected, oh man, these have to go in the right order now, don't they? Expected range, expected X, expected Y, expected team, expected hit points, and I don't even remember which ones we did here now. I think we need a couple more. So this is the problem with having so many different arguments. Hopefully PyCharm is going to tell me which one was which, but it's not right now. So we'll go look. So attack power first, great. We could go and name them if we want to, right? We could do named arguments. That feels like a little bit of work here. And then hit points next, expected hit points. All right, and what comes after hit points was X position, Y position. Okay, there's X, there's Y. And then after X and Y, we had team and then range. Team and expected range. Cool. What does it not like about this? Oh, because range is already a word, right? That's probably okay for right now. We're not going to use that inside of it. Great, now we've got the unit. Now we have to go get the values back out, right? So we'll have all these things, but we want the actuals here. So let's replace this with actual here. And I just want to grab that one. So not exactly a quick copy paste, but relatively quick copy paste here. Like, this is the longest part of testing here, which is kind of boring, but that's okay. We'll say, okay, that's my unit dot get attack power. Unit dot get hit points. Unit dot get range. Unit dot get X position. Unit dot get Y position. Look at that, it's suggesting it here. Unit dot get team and unit dot get, or no, is alive. Look at that, so we're testing all of our gets. So we passed a bunch of stuff through. We should get all back out. Then we need to assert they all are equal. Assert are equal. Where is it? Self dot are equal. Equal. Self dot assert equal. That sounds right. And we do a bunch of these, the expected attack power and the actual attack power, right? And we just copy paste a bunch of these. 1, 2, 3, 4, 5, 6, 7. So we have attack power, we have hit points, and hit points. And then we had range, and range. And then we had X and Y, expected X, actual X, expected Y, actual Y, team, expected team, there we go, and the actual team, there we go, and then the last one was is alive. Expected is alive and actual is alive. All right, so we've tested out all the gets and the is alive function here and our initializer, our constructor here, and give it a quick run. And it passes. Good. So seems like ChatGPT wrote fine code. Not super, no big surprises here. Now the interesting one though is attack, right? Attack is really doing most of the work here. Right? So we've tested all those ones here because attack will call damage here when that happens, right? If it should. So with the idea of getting 100% code coverage, wasn't required. I just said, hey, write your tests here. Have the test. But we probably want to check that it doesn't attack someone it shouldn't attack, that it doesn't attack someone not in range, and that it does actually work when it should, right? So we probably have 3 different tests for attack for this, because we want to make sure all of the things we told it to do work. Now, one test, sure, does it do what it's supposed to do is good, but also does it not do what it's not supposed to do? It's good to know and making sure we're testing all the right stuff here. So this is like, I don't know, attack successful. Maybe we'll do that one first. Now we need units to attack here for this to work. So we'll have arrange, act, and assert. So real quickly, we can know if I start a unit with 10 hit points and it loses 5, it should go down to 5, right? So I need a unit to attack, right? Unit to attack here. And then we'll go give it a bunch of values here, right? So we don't really care what its attack power is. We said if we had 10 hit points, great. We'll put this one at 0, 0, maybe. And then team is, I don't know, them. Doesn't super matter here. And we can even leave out range, right? We don't even need it. And then we have a attacking unit here, right? Equals a unit. And basically it can be the same thing. Hit points, attack power, but let's just move it, right? 1 and 1, maybe. And then we'll change its team to us. So us should attack them, right? That should work just fine here. And then we'll have an expected hit points after attack. Should be 5, right? 10 minus 5 should give us 5. Now let's try it. So we'll call the attack code. That's what we're testing. So our attacking unit dot attack, the unit to attack, and then the actual hit points is equal to my unit to attack dot get hit points, right? And then we should assert they should match. Self dot assert equal my expected hit points and my actual hit points. Do we want to add? We don't really need to add the after attack. I just thought that was fun here. So this one should work, right? If we did it right here. Okay, attack successful. Good so far. Now we haven't checked any of the bounds checking with our hit points. Like if we do more than 10 hit points, do they stop at 0? So you could have test after test after test after test. It's all good, and we should, because we wrote the code. We probably care if it works here, right? So sure, let's just go copy paste. So let's add another test here. So this is test hit points don't go below 0. Why not? Sure. So let's add our attack power is like 50 for the attacking unit, and we should have 0 when we're done. It's the only thing we have to change because everything else is variables. Should work out pretty nice, right? All right, and then we need another test for attack here where we don't attack, right? So don't attack same team, right? So my hit points should stay at 10 if we're the same team. So for both us, then I shouldn't attack. No hit points should move, right? If we're the same team. Cool. And then one last one here. I want to don't attack out of range, right? Out of range. So if we move the units here to like 5, 5, and our range is square root of 2, we shouldn't attack. They should still have 10 hit points. Like, hey, you tried to shoot, but you didn't have any room. Okay. So lots of different cases here because we had this check and this check and this check, and then this one does this thing and this one does this thing, and you know, those sorts of values here. So, you know, we didn't actually test this one yet. We could in a little while. We could get to that. You know, it's going to happen when we rally. Those sorts of things here. That makes sense? All right, so we got unit. Now let's go to infantry. So infantry then is a type of unit. Sorry if that wasn't super clear, right? We should inherit from unit. We have a different attack power, we have a different hit points, and then we can move differently. Everything else is already done, right? We still attack the same way attacks work, right? We just have different values here. So we get attack power and hit points. We get the default range. So I'm going to make a new class here, or a new module here. So we'll call this infantry. And from unit, import unit. And this is our class for infantry, infantry, which extends unit, right? Inherits from unit. If our parent class, no, not iter, init here, has an argument, right? It's warning us. Oh, come on, is it warning us here? Init. There we go. add the superclass call. It generates some code for us, which is super nice. So we don't need to ask for the attack power because we know what our attack power is, right? We don't need to ask for the hit points because we know what the hit points is, right? Tell me what your X and Y are. Tell me what team you're on, right? So attack power is 5, hit points is 5. You tell me the X and the Y, you tell me the team, and now we're also going to pass in range though, right? So our range, what did we say, was 5? Oh no, I'm sorry, this one had the default range, my bad. We don't need a range, right? So you just have to tell me X, Y, and team to create a unit, or to create an infantry. And then we have to do something special with move. So the only thing we're doing special is move, right? So move takes a X move and a Y move, right? So now we can, depending on how you want to go about it here, you got lots of options. We talked about exceptions already, right? We did that last semester. I think we talked about them a little bit this semester, exceptions. So remember, Python is truthy. So if it's 0, it's false. Anything other than 0 is true. So we can say if X move and Y move, raise a value error, unable to move both X and Y. Right? Just to be cute, it's just assuming it's the same as saying not equal 0. Right? It's just, hey, look, I saved 4 characters. Yay. But this is pretty common. You'll see this a lot in Python, right? We rely on that truthiness. If it's 0, it's false. So if both of them have a value, right, I can't do that because I'm only supposed to move 1 or more, right? Either X or Y, no more than 5, right? So then I can check, hey, if X move is greater than 5 or Y move is greater than 5, we can raise another value error, right? Able to move more than 5. Sure, right? And again, having this 5 in here might be a little bit ugly. We might want to have some sort of, max move is 5, and this is going to be a little cleaner here. So say self.max move, self.max, right? Just put a name to what's happening. Like, why is it 5? Well, now I know, okay, that's your max move, right? Just puts a nice name to it. Again, optional, it's a good habit to have these sort of like static values here. Okay, so we got that one here. If we didn't raise an exception, great, let's go change it here. So self.x position plus equals the X move, and self.y position plus equals the Y move. Now, one of them should be 0 if I got this far. So adding 0 is not going to hurt anything, right? I don't need to do another check here, right? So I'll just change it. Hey, you want to go negative? Sure, you go negative, right? You can add a negative number. That's subtracting. So move. I think that works out pretty well. Excuse me. Right, so that should be infantry. So the only thing we really need to test then is move, right? That's the only new code we wrote. We called it the init method here, but there's no actual code happening. If we wanted to, we could check for defaults. Hey, a new infantry has an attack power of 5, a hit points of 5. We could do that, right? It's not going to hurt anything to do that if that's what it should be here. And maybe we add those as well, right? We have a attack power is 5 and a hit points is 5. We can do that because that's probably, again, a little bit nicer, right? Self.attack power and self.hit points. Yeah, look at that. It puts a nice name to what's happening. Just a nice thing to do here. Let's go test it. So let's go to test. Hey, we don't have any tests. Let's make some new tests. Great. Testing for move here. So we're going to arrange, we're going to act, and we're going to assert. So this one, I don't know, test move works. Is success, whatever you want to call it here, right? So we need a expected X position is, I don't know, 5, and an expected Y position is 0. And we have to go make an infantry, right? So from infantry, lowercase, infantry, import infantry, uppercase. So infantry equals infantry, given, okay, what does it need to know? It needs the X position, the Y position, so we start at 0, 0, and really the team doesn't matter. I'm just going to put an empty quotes here. I have to give it something, but we don't care what the team is for this point here. We'll call move, right? So our acting, we're testing move, so we'll say infantry, infantry.move, and what do you want to do? We wanted to say X should go up by 5, so 5 and 0. This should work, and they'll have an actual X position. my infantry.get x position and my actual y position. Infantry.get y position should not have changed here, and then we'll assert their equals, right? 5 should match 5, 0 should match 0. Self.assert equal, my expected x, expected x. I guess I could have done any order here, but that's fine. And then, sure, I'll just copy paste here instead of typing again. Why not? We'll have y and y. Right? Cool, so that one should work. That one passed. Now, again, we wrote code to make sure we only do valid things, so we should probably check it, right? So test move fails both directions. I don't know if that makes any sense, but sure. So should be at 0, 0, right? If we try move 5, 5, we should land at 0, 0. Let's run this test. Oh, it fails because we ran into an exception, right? Okay, we need to go handle this. Now, did we use a try? There's like an assert where you expect an exception to happen here. I'm trying to remember. It's been a little while since we did it here. Python unit tests for exceptions. Let's see what the internet thinks here. Again, we could wait for the Bing code to generate, or we could just go to Stack Overflow here. Assert raises. There we go. So assert raises should do it here. So move then should cause an exception. So we want self.assert raises. And when this should be a, what is it, a value error here when we call infantry.move 5, 5. Right? So it should raise an exception. Then our position should not have changed. Right? We should still be at 0, 0 because nothing worked. Oh, did that not work either now? Did not catch it. Self-assert raises. Oh, we didn't. Do I have to do this different here? The passing arguments? Oh my goodness, that's really ugly here. The function and then the arguments. Okay, so we need to give it, so we won't call the function itself. We say infantry move, comma, and then the arguments. Right, so remember, you can pass a function as an argument because it's really fun nonsense stuff here. Let's see if this one works. I think this is why we just did try catch. Hey, that passed. I didn't think that was going to work. Thank you, internet. And hey, you know, we should cite our source. This is academia, right? Awesome. So we tested our exception. We got a value error. We could even test the message if you wanted. That's one step further. Like, I don't care what message we spit out. You know, sure. We just have a value error. That should be fine. And then one more here. Should raise an exception, fails more than max. So if we try and move like 10 here, which is more than our max, it should fail. We'll give that one a try. Hey, that one works too. Very exciting. Our test passed. We're very happy. Okay, so there is infantry. Class is done. Now we're on to artillery. Same thing, different things, different move requirements here. Just slightly different, right? So make another class for it. New Python file. This is artillery. Artillery, that's probably close here, right? And then from unit, import unit. Class artillery is a type of unit here. Define our init method here. And init says, hey, you have to do something here, right? Yeah, thanks. Give me my code, please. Now, we know what our attack power is, right? We know what our range is. We know what our hit points are. Right? So I don't need attack power. I don't need hit points. I just need X, Y, and team. Right? So attack power then, you know, hey, we'll have attack power. What we say was 10, range was 10. And hit points was 1, and then max move is 1, right? We can do that. So we just pass self.attack power, uppercase, there we go. Self.hit points. Now this one does need the range passed in here, right? So self.range. Okay, that's our init. Cool. And then we have move, right? We only move one X or Y at a time. This is starting to be a little bit obnoxious, right? Because we just did all this move stuff here on this side, and I'm going to have to copy paste the code. Well, what if, I mean, all of our units say they can only move one X or Y at a time here. So if it's shared behavior, we should move it, right? So really, I'm going to take all of move here. I'm going to cut it out, and I'm going to put it back in unit. So let's change this one move here to do this, but now we don't have a max move is the problem. We don't know what this value is. So maybe we need to pass it, or maybe it just needs to get set somewhere. We've got some options here. So probably makes sense to set it, but it's probably like a private value here, right? So we'll have a max move here, a self max move. So let's go add that as an argument here. Hey, you want to make a unit? You tell me what the max move is. Again, just an option here. So max move is 1 to start until we know otherwise, right? We can then say self dot max move is max move here. So then for infantry, we can pass in the max move of 5. Max move is 5. For artillery, we can pass in max move of 1. Right? You pass those ones in. So now my test really for infantry, all of this can move then. Maybe we still want to make sure it does 5 when we've successfully passed 5. Maybe that's nice to know, but the code does work. We know the code works wherever we test it here, so we got options. So really that's it for artillery. And then cavalry does the exact same thing. It's just 5, 5, 10, and 10. Right? These classes get to be a whole lot less interesting the more code we move to the shared unit class. If you have the same code twice, it'll work. You're just going to feel bad about yourself, right? You did more work than you needed to here. So if cavalry from unit, import unit, class for cavalry, extends unit, right, is a type of unit, and we'll define our init method here. Yes, please give me all this stuff. Come on. So we don't need attack power, right? We don't need hit points. We need X position, we need Y position. But then we also do need, what do we have here? Has a range, so we need to pass range, right? Range equals something here, and then my max move equals something here, right? So we'll have, I don't know, let's go steal from here. Max move was 10, right? Hit points was 5, range was 5. Hit points was it 5, 5, and range, attack power, hit points. Oh, no, range, attack power, hit points. 10 hit points, there we go, 10 hit points. There we go. Right, and really now it's the same thing here, so self.range and max move of self.max move. Pass those in. We have to, I'm sorry, we have to give it those other values too, we forgot. Attack power and hit points. There we go. We give it our attack power, we give it our hit points. That's cavalry. Not a whole lot here. There's actually nothing for us to test. The only thing it does is have these static values, right? Same with artillery. We didn't actually have any code here. Right? There's no code for any of these aside from its static values. So then the last one here is captain. Captain is an infantry, not a unit, right? So it's a type of infantry, and we're just changing its behavior here. So let's go make a class for captain. So we'll add a new module, captain, and then from infantry, we want to import infantry. Right, so class for captain is a type of infantry. So we'll define our init method here, and it needs a couple things here. It's a little bit different for this list here, right? So X, Y, and team, right? X, Y, and team. But now we're changing our attack power and our hit points. Self.attack power is, what do we say, 1, right? And then self.hit points was 20. Nope, let me just set attack power and hit points, right? There we go. But now how do I pass this to infantry? Right, infantry doesn't take those as arguments, which is a little bit of a bummer here. So either we have to take them as arguments, or we have to go change it. Right? Either way is up to us, right? However we wanted to go tackle that here. We could just go change it, right? We could say, hey, self.hitpoints equals 20, and then but then we have to remember to go change your max hit points. Right? It gets to be a little bit messy going in over, like anytime you're accessing these private attributes, yeah, it's a little bit sketchy, right? So maybe the better thing to do is to go and take those as arguments in infantry. And just a choice. We've got lots of different ways of going about it here. So we might take a hit points, but then default that to hit points. What is it? Self.hit points. And then, what was the other one? Attack power, right? Attack power, default to self.attack power. Why does it not like that? It doesn't like self. Can I just use hit points? Okay, and then we'll pass in here now our hit points, attack power, and our hit points. Right, I think that works here. So then we'll take we have to pass it those values. So we give it then attack power is self.attack power, and hit points is self.hit points. Right? We're passing those. So we're overriding. Cool, that's fun. We get that notice. Then the other thing we need to do is change our attack. Right? Attack takes a target. So this one now has some special behavior. Right? We're going to rally someone of the same team and restore their hit points. Right? So if they're the same team, right? So if self.team is equal to target.getTeam, then we'll go take our damage with, like -1,000,000 or something. Right? Restore all their hit points. It should stop at max here. This is a little bit silly here, but we could go get their max, but again, we don't really have access to max. We don't know that exists. Or we could do target.max hit points. Right? We know there's a value there. It's just warning us, hey, you shouldn't do that. So maybe we go add a public function. Maybe we just say it's okay. We got lots of choices here, right? There's lots of different ways to go about solving this problem here. Some might be better than others. That's all. If you're playing a game, usually you kind of display these sort of health bars that have, here's your max hit points, here's your current. So having a public function for get max hit points probably makes sense in the long run. Just a choice. We've got options here. So I kind of like the idea of adding it here. So we can go add that one here. We can go do that one ourselves, I guess. Define get max hit points. Return self.max hit points. There we go. Then we can go use that one in our captain class here. We feel better about ourselves. Get max hit points. Okay. Now this one we have to test, right? Make sure it works as expected here. So let's go to test because we actually have new code we wrote. And now we want to make a new test here. So test captain, test attack. So from unit, import unit, and from captain. Actually, we should just be able to do captain, right? From captain, import captain. So we're going to arrange. We're going to act. We're going to assert. Now, this should work if a unit doesn't have full hit points, something should change. So we need to have a unit that doesn't have full hit points to start with, right? So we have to go make a unit and damage the unit so we can heal the unit, right? To make sure the healing part works. So we need a unit to heal or rally, right? We're going to call it rally or heal, whatever we want to call here, right? Is a unit. And then what do we care about here? We got to need from unit, import unit. There we go. So unit needed a bunch of things here. An attack power, 5 hit points. We'll go 10, right? 0, 0. That's fine. And then a unit, or an attacking unit to go damage this one here. Oh, we needed team, right? So this was team us. That one's a unit. 5, 10, 1, 1, them. Right? And then we need to attack. So my attacking unit dot attack the unit to rally. Right? This is all stuff we're arranging. We already know this code works because we've tested attacks separately here. We're not testing any of that. Then we need the captain here. Is a captain. Given, and what does captain need? An X position. So they have to be within range of this one here. So I don't know, like, and what was the range for? It's got to be pretty close, right? So how about like 1, 0? Right? So it's close by, and it's got to be the same team as the unit we want to rally here. Team us here. Then we're going to act. The code we're calling. Oh, we'll have an expected hit points. Expected hit points equals should be 10, right? I should go back up to max here. So then we'll act. So we'll call captain.attack the unit to rally, and then we'll have an actual hit points equals the unit to rally.get hit points, and then we'll assert, did they match? Self.assert equal my expected hit points and my actual hit points. Right. After you took some damage, did you go back up? Right. Give that a run. Uh-oh. Didn't work here. We expected 10, we actually got 0. Uh-oh. Bummer. Well, let's see. So what do we do with captain? So, no, we did a bad thing here that we never even checked if we're within range. We probably should have checked if we're within range as well, because right now the captain can heal everybody. So let me add that in as well. So self dot is within range of the target. All right, so target damage. Oh, we didn't make this negative. It has to be the negative max hit points, because subtracting a negative adds. We just killed every unit automatically here. We just did max damage every unit. This ought to take care of that for us. Let's see. And this is why we test here, right? Because we're going to have typos. So testing for captain, let's try that again. Hey, now it's successful. Right? And if we wanted to, we could have another test to make sure it doesn't work if they're not within range. Right? So this is test attack not in range. So if they're at 10, they take 5, they should stop at 5, right? Should still be at 5, right? Making sure we didn't actually heal them if they weren't within range. Uh-oh. Expected 5 actually was 10. Oh, that's disappointing. Oh, I never moved the captain, right? The captain has to be out of range. Here we go. So we put the captain somewhere else here at like 2, 0. Right? Now they'll be out of range. Look at that. Our test code was buggy. There we go. All right. That took, okay, 50 minutes. A little bit longer than I wanted, but that's okay, right? We've been kind of talking through some ideas here. And lots of different ways to go about getting all these different things working here. I'm going to guess most of you have more code in infantry, artillery, and cavalry than I have. Just a guess, right? Again, I spent some time making sure I didn't have to write other code here for these, right? If you didn't go through that, that's okay. You can have the same code more than once. You can check all these other things, but then you have more to test, right? So inheritance lets us be lazy because we all want to be lazy. We want to be efficiently lazy, do the least amount of work that we need to, right? That's the goal. And again, you're not always going to get it the first time, and that's okay. The number one goal should be working software. We want software that gets the job done. Then we can look at how do we optimize it? How do we make it better? How do we make it cleaner? Those sorts of things here. But if you get stuck in how do I make it look good before you make it work, it's going to be really hard to get to the point where it makes it work, right? So that's why you want this sort of like iterative process here. Let's get working software and then tweak it and change it. Make it do what we want it to do here, right? Having done it for 20 years, it's a little bit easier for me to do it just kind of on the fly, right? You've done it for a semester and 4 weeks, right? So it's okay. That's the goal. And I think ideally that's why it's worth having me do these solutions, and it's not a big waste of your time to do them here. So I enjoy talking through the process, right? And that's a lot of what happens here. You kind of think out loud here. There's actually the technical term, rubber duck debugging here, where if you're having a problem, it's got its own Wikipedia page, I love it. If you're having a problem here, you explain it to your little rubber duck, and by going through the process of this, explaining it in English, you figure out, oh, that's where I missed a step. Oh, that's what I did wrong here. Because if you can break down your problem into English, like your pseudocode, here's your step by step by step by steps, little small steps here, and tell your little rubber duck, you can probably figure out where you went wrong in your code, right? That's why the CS50 AI is a little rubber duck, right? The CS50, it's their little rubber duck, right? It's talking to your little rubber duck chatbot friend here, which is fun. Have you guys used this one yet at all? Okay. I'm super fond of it. I think it's really cool. You only get like so many uses every hour or something like that because they're giving it away for free, which is nice. I mean, free is the wrong word, but someone else is paying for it, right? You don't have to pay for its use, but they've designed it to be a tutor more than a chatbot is nowadays that just gives you answers, right? So it kind of guides you in, hey, this is the thing you need to do, then you go do it, right? Which is pretty nice. So they're pretty fun. All right, so I think that's project one. Again, there's no code that does anything, right? Main is empty. We don't ask the user for any values. We don't output anything. We just wrote some classes and made sure the classes worked. We assume someone else on our team will do the interesting, pretty fun stuff and talk to users, and maybe it's a web application or a mobile application. Maybe we built it for our calculator that can run Python because that's always super fun. Who doesn't love Python everywhere? It's up to us. The goal of object-oriented programming is classes are portable. Right? If we tie our classes to input at the console, they're not portable anymore. Right? So classes should always deal with arguments and returning values. Right? How people interact with it, if you want to make a console-based program, go for it. They can use our classes for that. All right. So let me fire up GitHub here, and I'll go commit that. So here's project 0. Probably done. I think I got it all right. So again, just look at the rubric, classes and tests, classes and tests. I sort of cheated because they didn't need tests, but we tested it up here. So I would still give myself full points here. It's a bit of a trick, I apologize, but I don't think did anyone go down the road of not having code in your other 3 classes here? Okay, that's all right. And again, it's just maybe one of those moments you're like, oh, it's the same thing except for some numbers. That means it could be a function. Oh, that means I could share it. That sort of idea just when we did our functions here. That's why I like this sort of exercise. Just kind of fun and silly to think about here. All right, so we finished our array-based lists. The next thing we were going to do then, right, is talk about the next project, right? Okay, so let's do that one here. So we need project number 1. Here's as we do in 2 weeks on the 13th. What does that put us at? 2 o'clock, right? And this one's probably worth a couple more points here. Let's go like 12 here. All right, so let me submit the URL of the project in your repository, add a README file to the project folder with screenshots of it running. Again, there were no screenshots this time because we just didn't have anything, right? Is that okay? All right, so we'll actually have screenshots of it running this time. Here as we go. All right, and then we were going to do recursion for this one, right? I'm trying to remember what I told you on Tuesday. It's going to be our recursion project. Okay, so we did a couple of different practices, right? We did our 8 queens, right, with the Warnsdorf rule. Did anyone get this one done yet, or are you just waiting for me to show you on Tuesday? Right, I showed you the position class, how we can make positions and make them countable, right? I think in lab on Tuesday. But a lot of people were working on the previous lab. It happens, it's okay. One of these times I might change it so that people don't get behind on labs, but I don't know. Today's not the day. So that's the Knights tour. We did N queens in class, right? And we did the maze solver in class. Okay, so we need another recursive project. What was that? I'm not remembering, friends. I'm sorry. Let me go. Did we do our... I'm gonna look at our maze solver real quick because I don't remember how far we got with that one. We did recursion. Did our maze solver. Yeah, we had, okay, so we did number of steps, right, and counted our number of steps here. Number of steps, cool. Okay. So we did that one. I'm not remembering. I'm gonna go shamelessly look at what I did last time because I don't remember off the top of my head anymore. I should remember, and I don't. I got nothing. We're gonna have to go back a few semesters. Let's go see. So I try and like rotate some of these around every now and then. Where'd it go? Project. Ah, yes. Checkers. There we go. So easier than chess. It's checkers. You all familiar with checkers? My grandfather loved the game and I could never beat him. It drove me crazy. but then I went on to chess, and chess is much more fun than checkers anyway, and I gave up on checkers. I didn't get a whole lot of yes, I know how checkers works from you. Okay. So for checkers, we're going to build a backtracking recursive solver for figuring out the best possible move in checkers here. So we're going to have some sort of 2D list that has a board. We're going to assume all of our pieces are king. So in checkers, regular pieces can only ever move forwards. King pieces can move forwards and backwards. So we'll just assume everyone's a king. So you can jump forwards, you can jump backwards here. We got black pieces, we got white pieces, we got spaces here. So our init should accept a board, make sure it's a valid checkerboard. So with valid checkerboards, all of the pieces have to be on the same color. I don't remember if it's white squares or dark squares, light squares or dark squares. I don't care. As long as all the pieces are on the same color, you can play checkers. Right? If not, we're going to raise an exception. So here's a checkers board here. We'll go look up a checkers board. Those chess, didn't I say checkers? I said checks board. Checkers board. There we go. Now we're getting something better here. So here's our, oh, thanks Amazon. Here's a checkers board. So all the pieces are on dark squares right now. It's essentially the same thing if you just shifted all them over to the light squares, right? Just like take this row, put it down here, and then they're all in light squares. Okay, same number of pieces. So either way is perfectly fine. You pick. When you're playing checkers, you can jump pieces. Okay, so let me go, we can just draw it here, right? Why not? Let's not draw. We can do better. Let's go find a 2D checkerboard here. Oh, I want an empty one though, shoot. I want an empty checkerboard. Yeah, that ought to work. Let's try this picture. It's not confusing at all that it's diagonal. Come on, stop. All right, let's put this in Word. We'll draw on top of it here. That's fine, right? Okay, so we've got checkers pieces here. So maybe I've got a white piece here and a black piece here and a black piece here. That's a B. Oh my goodness. And a white piece here and a black piece here and a black piece here. Okay, so imagine we got some checkers, right? Any board we can set up here, perfectly fine. There's a bunch of combinations, don't worry about it here. So the white piece can't jump over this black piece because there's not an open spot to land. It doesn't matter if there's a black piece here or a white piece here. If it's not open, you can't jump. So we can't jump this direction, we can't jump this direction. We can jump this direction, there's an open spot to land and an opponent piece to jump. We can jump this direction, there's an open spot to land and an enemy piece here. Right, so we're checking, can you go this way? Can you go this way? So you can jump, right? So you could go this direction and jump over. So we would jump our piece here, take this one off the board and take our piece off the board. This is the next state, right? We've jumped over it, their piece comes off, ours moves. Well, now there's nowhere else to go. So this path had a maximum number of jumps of 1 here, right? Okay, cool, and then we backtrack, we undo, right? Okay, let's try the other way. Can I jump this way? Sure, well, let's jump this way. Okay, I jumped that one, this piece comes off, my piece moves. This one also had a maximum number of jumps of 1. Not very interesting yet, right? So we undo. So both of them are even so far, but now imagine we had a black piece over here. Okay, so you got a black piece here. This one is still, this path is still 1 jump here, but this path, right, if we jump over this piece here and move ourselves, now we can do another move. There's another jump, right? You're looking, can I jump this way? Can I jump this way? Just like our maze solver. Can you go up, down, left, or right? Can you jump? Can you jump? Can you jump? Can you jump? If you can, go for it and recurse. Go for it and recurse. We're going to do the backtracking. Eventually, we stop here, right? Okay, here's my white piece now. I'm over here. I have nowhere else to go. Well, this path now has 2 jumps, maximum jumps. That's my best path, which might not actually be true for checkers. I don't claim to be a checkers expert. We'll assume jumping the most pieces is probably best for now, right? So we're going to get the max jumps, returns the maximum number of jumps of any white checker can go. So for every white checker on the board, calculate the maximum number of jumps it can go here. So it's also possible then, right? Let's go undo and undo, put ourselves back in this state here, that if we had a different white checker piece here, right? If we had one over here maybe, right? We know this one's max is 1, 2, right? This white checker over here has some other options, right? It could go 1, 2, 3, or 1, 2, 3. Oh, that one's actually even better. Look, we can go jump here for white. That's 1 jump, right? And then we can jump here for 2 jumps, right? And then we can jump here for 3 jumps, right? And then we can jump here back to where we started because it's open, right, for 4 jumps. So 4 seems to be the max so far, right? We've got other paths we have to take, but with backtracking recursion, we're just literally going to try every single possibility and see which one gives me the maximum number of jumps, right? And we're going to do it for every white checker on the board. Well, this white checker has no jumps. Okay, that's fine. And 0 is a valid option, right? There might be no jumps, so max number of jumps could return to 0, right? There's just nowhere to jump for any of your pieces. That's okay, right? But this one, right, we said was 1, 2. This one had 4 maximum, right? It had other paths, right? It could go 1, 2, 3, 4 the other direction. It could go 1, 2, 3 this way. We've got a couple ways it could go, but we're going to try literally all of them with recursive backtracking, right? And figure out which one was the max. We did the same kind of idea with our steps, right? How many steps did it take to go in this maze here? We said, okay, this one was an 8-step solution. This was a 12-step solution. So we need to track which is the best one, right? In our case, best is the most jumps. Right? So with backtracking, you try it, and then when you're done with it, you undo what you did, right? So put it back to where it was, put it back to where it was, put it back to where it was, those sorts of things. All right? So we got 12 points for this one here. Let me go, I had a rubric here, right? Was it on this? Oh, this was 15. Let's go 15 points. Why not? Let's crank that. 15 points. We like it. So 15 points then. 5 points just for validating your board. Look at that, I was feeling generous. Okay, go for it here. This is project 1. So you got 5 points for, oh my goodness, I hate that garbage. Your init accepts the 2D list for a board and validates it. Right? Raises the exception of is not valid. 5 points just for doing that with your solver, if nothing else happens, right? Get those partial points. Then our get max jumps correctly calculates for 1 white checker, right? Sure, it calculates for 1 of them, right? Find your first white checker, go for it here. Then get max jumps calculates for all the checkers here, right? So don't worry about tackling them all at once here. Start with 1, then let's go find every white checker on the board. It's just another loop on top of that. We're also tracking max like at another, like it's a little bit more tracking here as we go, okay? We don't need specifically unit tests, but you want to test it. Right? You want to know if I give it this board, this is how many jumps I get back out, right? Whether or not you write a unit test or you do it in main, I don't care at this point. The last project made sure you could do unit tests. This one, it's on you. Whatever you prefer, go for it, right? Again, I like unit tests because I think the computer does a better job of, did it give me back a 5, and looking to see if it gave me back a 5. Because I make enough mistakes here, like I'm not going to be super careful looking at the console every time I hit run and see if it actually gave me a 5 back. I'm going to screw that up, right? The computer's less likely to screw that up than I am. All right, that makes sense? That's what we got for project 1. We got 2 weeks to work on that one. So upcoming then, one quick last look here at our syllabus. Next week, we move into new topics again. We'll come back to our stacks, queues, and decks. This goes relatively quickly here. I don't think we'll take the whole hour 15 both days to get through these. We'll probably do 1 for stacks, 1 for queues. We'll have a little bit of extra time to work on this, or we could just power through. You know, actually, I might have something. I think I have something on 2.4. Let me check and see. People keep trying to make me go to meetings. I hate meetings. That's why I have my mug. Like, I'm going to bring this to when they make me go to meetings. But I'll let you know. So we might have to shift around just to Thursday, but I'll shoot you a message and let you know what's going on with that. But I should be good for lab, at least. We'll do a lab on array-based sequences. We're actually going to go do some graphing, which is kind of fun. So we'll test out the timings and see how long it actually takes and graph them, which is kind of cool to see. Like we looked at memory size, like how much memory is it using, but we'll look at the time that it takes to run here, not just how much memory it was using, right? We did the mathematical, it's O of n on average, you know, worst case, best case, those sorts of things, but we can actually go graph it out, which is kind of cool because graphing is really easy in Python. All right, thanks folks. I will see you Tuesday for lab.